In this segment, we're going to talk about some newer ideas for understanding how to extend chain of thought prompting and how to analyze and understand maybe why it's working well. So we kind of went through this with few-shot in-context learning, thinking about all those properties of like example ordering and stuff like that. So we can ask some of the same questions about chain of thought and then also think about, okay, given what we know about what it's doing, how do we make it even better? So one of the things that we can ask is basically, are the language models actually following the explanations that are given? How important are the explanations and the prompts? Remember, we talked about that work that for in-context learning that showed that you could just mislabel things and stuff would still work fine. So is that the case here? So we can look at two types of perturbations. If you perturb the stuff in green here, you're just changing the language expression of what's going on in the example. So for example, in this case, we're just trying to concatenate the last letters of these two words. So a very sort of trivial operation, but it's still not that easy for a language model to do. And we can change up how we describe this. We can also change up the actual computation trace here, where we can introduce errors in, let's say the actual extraction of that letter that happens. That's what's shown in red. So if we look at these perturbations, somewhat encouragingly, we see that either of these things causes performance to drop by a lot. So compared to the purple bar here, the accuracy when you perturb either the computation or the natural language drops by quite a bit across three different tasks. The first one is this letter concatenation. The second one is this task about flipping a coin and tracking what state it's in. And the last one is this kind of math reasoning. And you see that one is kind of very negatively impacted by having kind of bad computation traces or bad natural language expressions of the reasoning. Now, one of the things that is kind of, you might think is, well, okay, it's really necessary to show the model the right kind of computation that it's doing, but particularly this last example of this letter concatenation thing seemed really trivial, right? Like we should just do that with Python and not with large language models. So there's been a lot of work to try to unify the capabilities of things like programmatic interpreters that can actually execute code with large language models. And in particular, all this focus on mathematical reasoning has led people to look at the fact that sometimes ChatGPT just makes arithmetic errors, and wouldn't it be great if it could not do that? So there have been a number of approaches, program-aided language models, program of thought, faithful chain of thought, toolformer, a number of methods for generating code fragments and then executing those code fragments and basically having the chain of thought reasoning not entirely happen in natural language, but happen in a mix of natural language and code. And it turns out that indeed this does lead to better performance for all this math reasoning stuff if you basically predict these code snippets and formulas and then have some way of executing them. There's another method for generalizing that same sort of idea to other tasks, which is called self-ask, where you take a complex question that you're going to answer and you break it down into smaller questions and ask them, and then equip the model with the ability to do things like retrieve information. So this is a lot like what Bing Chat and Google Bard are doing, which is they're able to take your query, execute some searches based on it, take that information and somehow integrate it into the actual response that they give you. So this is a kind of other really powerful tool that we can use because it enables the models to go beyond just what they sort of know in their parameters. So there's a lot of interest and excitement about the capabilities of this. We've seen two tools that can be integrated with language models, which are programmatic execution and search. There's a broader set of ChatGPT plugins that enable you to use other kinds of APIs. And when we have future models, they're likely going to be even more tightly integrated with all of these capabilities and probably fine-tuned to use this stuff to a higher degree. We haven't quite seen that yet, though. Another kind of element here is that when you have these chains of thought and you're doing this kind of reasoning, you want to check all of the steps of reasoning and make sure that they're all correct. And so there's a lot of interest as well in verifying the factuality of all of these things. And one way of doing that is to just ask the LLM itself to sort of check its own work. So kind of combining all of these ideas from chain of thought with these existing tools and with LLMs themselves is going to enable these to kind of go even further and do even more exciting things. That's the end of this segment.